live according to this system. Good evening from our side, and
Good evening, everyone.
whatever time you're looking at this video. I'm Frank Del Porte, and I'm joined here by Robert, also known as Eich, from the Pi4J project. And we want to have some fun with LED strips and see how you can program them with Java on Raspberry Pi. Let's just check if we are into have some fun with. Okay, this seems to be okay. Seems to be live.
Yeah, I saw it live on my channel too. So
okay, then we killed that window. This is what we want to achieve today. Is have some fun with this kind of stuff. So we have a demo running here with one simple LED strip with only 11 LEDs. A matrix which has 8 by 32 LEDs, and another one, a long LED strip of 5 meters with, I think, 60 LEDs per meter. So that's a lot of lights that we can have fun with. Let's see, we are both here again. Good. Now the idea and why we did this is because we got a question, Robert, from university where they are experimenting with LED strips, but it's not that easy.
no, it's LED strips are a difficult thing if you don't have the timings going properly.
Mm-hmm. And the timings meaning the electronic signal going to this strip to control the LEDs, correct?
Exactly. So LEDs, they like to have tight timings in how they receive their data packets. And as soon as you're using a multi-purpose OS like Linux or anything else, Windows, etc., you will have threads that just get stopped by the kernel. And so the timing when you want to send your packets are not always as properly timed as you would like. And so we need a way to keep those timings tight so that the LEDs can carry on, especially when you have long LED strips where your timings might get off quite badly, and then suddenly the rest of the strip doesn't function anymore.
Mm-hmm. So what we need to explain here is a LED strip is actually a long line of strips connecting from 1 to number 2 to number 3, and below each of these LEDs is a small IC, correct?
Exactly.
Yeah. So we send in a data signal with colors, RGB values, red, green, and blue. The first LED takes the data from the first, really from the string of data, it takes the first packet and then sends the rest of the packet to the second chip. And the second chip again takes the first package, sends the rest to the following one. Yeah. So that's
and when a long enough time pause is between packets, then the LED understands this as it's stopped, and it starts again from the beginning. And this is where the timing situation comes in place.
Okay. Yeah.
So if the first 5 LEDs get the packets in the right time, they keep sending it on. But then maybe the first one suddenly has a big time between a delay between the next packet, and then it thinks, oh, this was a reset of the data, and thinks this is its own LED data, and starts again from the beginning.
Yeah, and the timing issue can be solved very easily by using Arduino or Raspberry Pi Pico, which are microcontrollers, so they don't suffer from these operating system pauses because there is no operating system on these devices. But yeah, we are Raspberry Pi guys and Java guys, so we want to do it differently.
Exactly. We like to use our high-level programming language and like to use our real-time operating system and, of course, Java.
Yeah, indeed. Okay, we found a solution in Electromage. Let me show you that. Electromage is, I think, two American guys. They have a company and they make a small device based on an ESP32 and a Raspberry Pi Pico, and they have this fancy mobile phone app where you can control one or more strips, and they have some fancy stuff that they are doing with that. By the way, we're looking at the screen of my Raspberry Pi, so if it's not that fast, that's the reason probably. It's a Raspberry Pi, I think the 4 with 4 gigabytes that I'm using in this presentation. So you can make this kind of fancy things with their Pixelblaze. Now, if we look at the products, so they sell all this fancy stuff and this Fibonacci-based matrices, which are really great and really fun for makers to build beautiful stuff. But the product that they are actually selling is, for instance, this one, the Pixelblaze Pico. So that is a Wi-Fi enabled device, which is very small, and you can control it through your mobile phone. That's not the thing that we're going to use today. We are looking at the Pixelblaze output expander, and that's this little board. And why I found this one very interesting is because it can control up to 8 LED strips that can be connected to it, and you drive it through a serial communication. And I think a serial communication is one of the oldest communication types with electronics, correct?
Oh, good question. I'm sure it's one of the oldest. Yes, definitely.
Yeah. And it's pretty simple to set up, and that's also a big advantage. Let me check. I got this very fancy movie from the creators of the Pixelblaze, and they used this at the Burning Man festival, and they were able to drive a lot of LEDs. They're talking about 110K of pixels per second that they are controlling, and they are actually also using Java. So they're using a buffered image, they're using graphics 2D, to use fonts and images and sprites, Java AWT, and they can produce animations of 90 frames per second. So based in combination with the music, it's quite psychedelic, but it's also very impressive what they're doing here.
It's wonderful to see what you can do with Java, as people always think it's not for hardware, it's not for embedded stuff, and that you can drive this many LEDs. Of course, yes, we are using a special purpose processor with a firmware that is actually understanding a protocol from Java and then properly driving these LEDs.
Yeah, indeed. Yeah, and I was also impressed with we showed the demo. By the way, the demo is here right behind me. If someone was thinking that there was some lightning behind my back, but that's really that are running there. Okay, what are we also going to use for this demo is JBang. Let's go back to the screen and show you JBang. Sorry if I'm a bit switching between screens the whole time. JBang was actually a real discovery for me. So it's a tool to run single file Java applications. That's something we could already do with Java since I think version 11. But the fun thing that they add is that you can define dependencies. So you can create a Maven project without the need to create a Maven project. Is that a good description?
Exactly. Yes.
So, you can see it here. So you define the dependencies inside your Java file. So in one single file, you're able to define a whole project. Let me look at one example. I find this JSON parsing example really nice, because that's something that a lot of people will know from their daily Java job. So in this example file, I've used the Jackson library, FasterXML, which can be used to parse JSON. And you see that the dependencies that you normally define in your POM file for a Maven project or in the Gradle file are inside the Java file. Right? And there's one extra thing we need to do here. and that's this first line to tell JBang that it is a script file and it needs to be run like Java. I don't care what it really does, but it needs to be there. And then we just have one single file which has some JSON, and it really handles this as I'm using a Java record here to read this JSON together with an enum and stuff like that. So let me stop the other. And you run it instead of using Java and the file, you use JBang. So it's JSON parsing. And now JBang will actually take a look in this Java file, see these dependencies that are defined in there, we'll download them if needed, and then create a jar file and run the jar file. So all in one command. So actually we get here the JSON output as we expected. If we run the same example with Java, then yeah, this faster XML library is not part of the base Java, and it just throws a lot of errors. And this JBang is really a nice tool to play with Java and create simple demo application. And actually, that's what we've been doing for the Py4j project. Is a lot of these kind of examples. You can find them online in GitHub. If you go to github.com/py4j/py4jgbang, you will find all the examples. So also this JSON parsing example, but also the LED matrix example that we will show, and the LED strip examples. And there are also others here, like for instance, reading the temperature, humidity, and pressure with a specific sensor. That's also part of this project. And if we have some time, Robert, we will add some more. Correct?
Yes, I already have a few ideas. One is an LCD display that I want to attach, which I already have a running example going, which I will then soon add to the project, which is running over I2C. So yeah, this multiple ideas, and to make this a larger project so that people can just well, copy paste the code and do what they want, and that is get their project running without worrying about the technical hassles of how do I do this and that.
Indeed, yeah, and that's what I really love about this JBang. It makes it so easy to run something like this. There's one thing that we can also show. So on the Py4j website, py4j.com, we have added a page that describes how you install JBang on a Raspberry Pi. It's not difficult at all. So also with this explanation what JBang actually is, it's only running one curl command, and I will install JBang. And during this installation, the tool will also check if Java was already installed. So if you've started a new Raspberry Pi with a new SD card and there was no Java on there, running this single curl command will install both JBang, and JBang will then install Java for you. So you have everything with this single command.
But there's one caveat. I did this today, and I had a version 17, Java version 17 on my Raspberry Pi, and I tried to run these scripts, and it didn't work. I installed in Java 21. I don't know if another version would work, but after installing 21, it worked. So yeah, sometimes there might not be proper explanations for the errors that you will receive. It was a compile error. It didn't find package or classes, but yeah, so just as a caveat for those listening in now.
I think there's also a way you can also tell JBang to use a specific version. So maybe that could also be a solution in that case. But
yeah, it might have been that some of the libraries might have been updated or something. I'm not quite sure.
Okay, but we'll probably not have that error now because
we tested it.
We already tested, but yeah, this is a demo and this is live, so something has to go wrong. Okay, so we explained Pixelblaze, we explained JBang, the wiring. We also need the wiring. What
exactly?
Yeah, how did we connect all this? Let me go to this page here.
Frank has written a nice tutorial already.
The tutorial is there indeed. We will add the video that we're now creating also to this tutorial to make it as easy as possible to get started. So what is the Pixelblaze output expander? It's this little board that you see here. It comes in this bag. And you see how it is connected here to a Raspberry Pi. And this wire here is going to an external power supply. More about that later. So what is the connection that we have between the Raspberry Pi and the Pixelblaze output expander is a serial connection. And serial normally has a wire for the transmission and for the receiver. So it is a two-way communication. But in this case, the Pixelblaze doesn't send anything back to the Raspberry Pi. So there is only a connection from the transmitter port, serial transmitter from the Raspberry Pi to the receiver side in the Pixelblaze. And the other one is connected to the ground. By the way, we have a closer picture of this here. So you see on this third pin, with the black one is the ground and the blue one is the serial. We can check that on api.py4j.com. So we see we are here on this connector. Pin 6 is the ground and pin 8 is the UART, so the serial communication, the transmitter side. So the receiver side is not connected because Pixelblaze is not sending anything back. Okay, let's go back to the previous image. So here we see the blue wire, which is the serial communication. And then we have a 5 voltage connection, the plus and the ground again. And here we have the connection to a LED strip. So let's look at the LED strip. Or did I? So this is the LED strip. Again, red wire is for 5 voltage. The white one is the ground. And the green one is the data signal that's coming from the Pixelblaze. What is the full name again?
Pixelblaze output expander.
I already said it 5 times. I forgot.
Because we always just think in the PBB.
Yeah, in the documentation, I shortened it to PBOE. Yeah,
PBOE, exactly. There we go.
There's one thing, and I again forgot it when I started experimenting, is that there should be a connection between the ground of the Raspberry Pi and the ground of the power supply, which is, I'm using this black cable here. I'm not an electronics guy. Maybe you can explain why it's different, why it's important that they need to be connected to each other.
Well, I had to look it up before the stream as well a bit. I'm not that much of an electronics expert. But yeah, the idea is that if you send signal out on the data line, the serial data, somehow you have to have a signal coming back so that actual electrons can flow. And that's why you push, you need to have a ground coming back as well. And you would put them together with the other ground of a different power supplies as well, so that you can actually have a signal coming back to the Raspberry Pi to actually close a circuit. In the end, what we're doing here is we're building a circuit, even if we're not just powering an LED or a light bulb. We are still building a circuit, and circuits, as the name implies, is always a circle, so something has to come back.
Yeah. And if you don't do this, then again you end up with timing issues, and the LED strip will do something, but not the thing that you were expecting.
Exactly. I think what this will mean is that you have a floating signal, so you don't even know if it's properly reaching 0 or 5 volts, and thus doesn't properly create the signal that the LED expects.
Yeah. Okay. So we have the connection, we have the ground, which is shared, and then it's also important to configure or enable serial. I don't know if that was already by default. So if you go to interface options in Raspberry config, there are these different things that you can enable and disable. I know that SPI and I2C are not enabled by default, but we are using serial. And in this case, you have to select no and yes in the next screen to enable serial. Okay, but I just did escape. I don't want to mess up my example here. Okay. There's also something which could be important if you start experimenting with this Pixelblaze, and that's this one, is the status of the, let me try to show you. You see on the Pixelblaze, which is in the middle of the screen, this little orange blinking LED. If it's fading like it is now, it means that there is no data being received, which is normal because everything is static. If it's solid orange, that means that it is receiving data. And if it's green, but that's only for a very short time, it is sending it to the LED strips. So at this moment, it is waiting for a signal. And you see, I stopped the code to show you the other JBang example. All my LEDs are now static because these LED strips remember the last state. So as long as you don't clear them, they will stay lighted like they were in the last command that they received. So that could be handy. So you can just fire up a program, put something on a display, for instance, and then shut your program down again if needed.
Exactly. That's a nice
Yeah.
thing about the LEDs. Yes.
Okay, so I think we have explained everything, how to set it up.
We do need to talk about the power supply a bit.
Yes, indeed, the power supply. Let me show you. You can see it here on my demo environment. It's the big aluminium block on top. I have a 40 amperes power supply of 5 volts because in my demo I have a lot of LEDs. How can we calculate this, Robert?
Well, if I remember correctly, an LED takes about 20 milliamps. And so you have there a matrix of what, 8 times 32?
Yes, 256.
So 256 times 20 gives you already 512. So 5,000 amps.
5 amps was probably
5 amps. So you're already using 5 amps just for the LED matrix. And then you've still got the LED strips, etc. So yeah, you need a lot of power for all those LEDs.
And this can be a bit dangerous because you can use just the voltage, the 5 voltage that you can get from one of the pins of the Raspberry Pi, can be used for a LED strip, and it will work up to maybe 10 LEDs. But if you have more, when you are above the 200 milliamps, then I think you can get into trouble and your Raspberry Pi cannot supply that amount of amps through one of the pins. So that's where you need a separate power supply.
Yeah, this happened to me. I did not heed Frank's warnings, and I forgot to add a power supply once I added my 8x8 matrix. It all worked fine with my LED strip. We only had a few LEDs, and I would never turn them all on at once. But when I used the LED matrix, something didn't work, and I thought, what did I do wrong? And then I suddenly realized that the light on the Pixelblaze output expander, it was very dim. And I thought, okay, something's weird. And then I realized power's missing.
Yeah. And
So I think everyone will probably run into this when they go just dive into it and don't read all the documentation. In this case, nothing happened, but you never know if you do suddenly burn out a cable. Maybe you took too thin cables and something happened. It could possibly happen.
Yeah. Okay, but be warned. Have a separate power supply and then mention it correctly for the amount of LEDs that you want to use in your example. Okay, Should we look at some code? I think so.
I think so. It's time for some code.
Time for some code. Okay. We try to make it easy by having a helper method, a helper class. So we have the Pixelblaze output expander helper. Oh, I love the naming of Java classes. And there are only a few public methods here because we are hiding the serial communication because you don't need to care about that, correct? That's...
I would say so, yes. Usually that's not important. You just want to turn an LED on and off.
Yeah. So we have some, so for people who want to know it, so we have another, actually this code is something that I got from the creators of Pixelblaze. They just sent me this. This is how we do it with Java. And I based the further examples on top of that. So it opens a serial port. You have to define the address of that port. It sets the bit rate. The bit rate is really high, is the amount of data that is sent per time unit.
2 megabits per second, yeah.
2 megabits per second, thank you. That's the kind of knowledge I lack, thank you. Then some other options, and then open the port. And then there is also a close port, because you always want to, just like you normally close a connection to a file or a database, you also want to close your connection to your serial port. And sending colors, let's see if we can find that, is actually, there's one important thing here, the bytes per pixel. And that's something you need to look at when you buy LED strips. Some LED strips have 3 colors, red, green, blue. And if you want white, you have to put them all 3 on. That's how you make white. Other LED strips have RGBW. So they have a separate 4th LED inside that 1 pixel for white. So you can have clear white if you don't use the other 3 ones. But in my examples here are all 3 bytes per pixel, so 3 colors per pixel, RGB. And then sending colors, so you have to define the channel, because the Pixelblaze output expander has 8 channels, so you can connect 8 LED strips to it, so you can send different colors to each channel. Then a byte array, and the byte array is actually a value between 0 and 255, so a byte for red, then for green, then for blue. So you have 3 bytes per pixel.
Exactly, which gives us 16 million colors if we calculate that correctly. So it's back to the old days when we still had VGA graphics.
Yes, indeed. And what I find a bit difficult is to get a dimmed color. So, but we'll maybe come back to that if we try the JavaFX example. And then debug is just to put extra logging if you're running this application. If you put on debug on the Raspberry Pi, the output will not be that fast, because it slows down how the whole Java application is working on the Raspberry Pi. So only use it when you really need to debug something. Okay, so this is a helper method which is available. So let's look at the first example where we use this. So it's a JBang application. This means that we have this first magic line here. Then we need a dependency. In this case, we are using a dependency for the serial communication. That's the Facecast G serial com library that we are using. And we are using that helper method is a source file that also needs to be loaded. So normally, if you would have Java code in a Maven project, this would not be needed, but that's what we have here for JBang. Now, what we also did, that's with practically all the examples of Py4j, is we try to add a lot of info also here, Java doc, how you can use it. So it links back to Electromage, how you need to wire it, but that's all stuff we already discussed. Now, in my setup that I have here, so I have the short strip has 11 LEDs. Then we have the LED matrix of 8 by 32, and we have the 5 meters. So if you go back to the code, That's what we see here. So the short strip is on channel 0, the long strip is on channel 1, and the matrix is on channel 2. And then the long one has 11 LEDs, the long one has 300, so 60 LEDs per meter, 5 meter. And the LED matrix has 256, 8 by 32. Okay.
Wonderful, yeah.
Yep. And then it's just a walk through the code. So we have a helper method that we're using is this Pixelblaze output expander helper. This is the address of the serial link of the Raspberry Pi. I think this is a fixed address.
Yeah, the Raspberry Pi will have a fixed one, but it might happen that you are using a USB controller to actually USB to serial, so that might change. So do check what you're using, but if you directly connect as we did with the wiring, then you will be using this address.
Yeah, and that's really the fun thing about this, because we're working with the Raspberry Pi here, but there are a lot of very cheap USB to serial connectors that you can find on eBay or wherever. So that means that any PC with USB can drive this Pixelblaze output expander through serial communication.
Exactly. So you
yeah,
don't really need a Raspberry Pi, but yeah,
it's just fun.
it definitely is. And it's something simple to put away in a cabinet and let it work.
Yeah, and then you can have this very fun effects like we had behind my back. So the helper has a send all off to turn everything off. I added this here because if you stop the code somewhere in between, you could have something still on one of the LED strips. So that's why this is here. And then some helper methods. Send one by one is just turning one LED at a time to red, I think. Yeah. So here RGB, red, green is 0, blue is 0, with 250 milliseconds in between each LED. Then we will put all the same red, green, and blue on the short LED strip. Then some random colors. And this is just playing with byte arrays, actually. So you see that each time we start with a byte array, which has the length of the number of LEDs multiplied by the number of bytes per pixel, so 3 RGB. So that means if a LED strip, the short one, has 11 LEDs, and there are 3 colors per LED, that means that we have a byte array of 33 bytes. And the random function is used here to just put random values in that byte array. Red alert is just a full strip with red, and then toggling it between red and all off. And then for the long strip, sending red, green, blue, and then flash something on the LED strip. You see all different examples of how you could use byte arrays to send colors to the LED, to the strip. So let's just try this. So let's switch back here. I will also show you normally the output there. So I use JBang Pixelblaze output expander.java. Okay, give it a short time to start. So it cleared all of them. So we have this one by one red. So all red or green or blue. Then some random colors. Now we have red on each of the LEDs separately in the long strip. We'll do the same with green and blue. So here in between, it's 20 milliseconds, I think. So really fast. So I'm really impressed that it's so easy to have that kind of fast animation on such a long strip.
Yeah, and you never see a lag or anything. So that's the nice thing about what the Pixelblaze does in conjunction with the data it receives from Java.
Yeah, I really like it. It's simple with the serial communication. It's simple because it's just a byte array that you need to send, and you can just put anything you want in there. I have this 8x8 matrix.
Before we go there, can we quickly talk about some of the parameters in those methods.
Yeah, definitely.
Because something that some might find a bit interesting, go back to the previous example.
Yeah.
So you have you send by one, or if we look down below, you have the helper send colors, right? We have an RGB index,
Yeah,
RGBW
indeed.
index. I
Yeah,
think we should explain what that
indeed.
means,
I
because
have
that
an
can
issue. Yeah.
be shown off.
Yeah. I have been doing web programming and video stuff for, I'm getting old, so a long time. And it's always been red, green, blue. Red is first, then
Definitely.
green, then blue. And when I started experimenting here with this Pixelblaze thing, I didn't get the right colors. It just didn't match what I was expecting. And it turned out that for some reason, they are not in the same order. So green seems to be first, then red, and then blue. Or I totally misunderstood something.
No, that's actually absolutely correct. So if you would look at the LED specifications, the you will see that it always expects actually the colors to be GRB. So
Okay.
green, red, blue. Yeah, I don't know why they decided that LEDs should be different colors. I have a feeling that it might be because of the voltage that is required for the different colors to actually turn on.
Hmm.
So blue needs, as far as I can remember, the most voltage,
Mhm.
and green being one of the earliest LEDs it ever created, I think, if I remember correctly, probably maybe needs the least amount of voltage.
Oh, okay. I didn't know that. Thanks. Learned again. But indeed, that was important to point out. And if you have a four LED, a four color LED, so also including white, then you probably also need to set this white index.
Yeah, I would suspect that in this case, this will always be 3,
Yeah,
since it will be the fourth LED added, and they want to keep the specification of all the protocol on how to communicate with LEDs probably very similar, or actually the same, just adding the white. So that will probably be a 3, but in this case, it doesn't matter which value you add, as it will be ignored anyway.
yeah. In this case, it's ignored because you only have 3 bytes per LED. Yeah, that's correct. Okay. Yeah, that was a good one that we needed to explain. And then we can go to the matrix, I think. So the matrix is a bit different. Let me first start with the other one because I have here an important one. I was assuming, and I think I have a visualization of that here. So if you have this this matrix, so it has 8 rows of 32 LEDs, and I was thinking that's how I would make it. That it's just you enter with your signal in the first row, you go through all the LEDs in that row, then you go back to the beginning of the second row. So that would be the kind of wiring I would use, but that's not the case. And I can maybe show it, that will be easier. So if I start the other example, JBang, Pixelblaze, matrix. Yeah, wrong. Which matrix? 832. You will see as first of the one things being sent is again that 1 by 1. And this is exactly how they are wired. So they're up and down the whole time, up and down. And that was a bit confusing.
To say
Because,
the least.
to say the least, because I was trying to put some images on there and my images were completely scrambled. But yeah, we found a solution, and Robert, you separated this in a separate helper method. So you will see there are some images here in this, but they are very small. So this is a black image with one line. So the same for this one. So it's just an experiment to see if we could use images, load them into Java as byte arrays, and then put them on a LED strip. I also have the Raspberry Pi logo, but as we only have 8 rows, it's very difficult to make this a real drawing. But the idea was to load these images and put them on the LED strip. So we have this ImageHelper class, and it can load from a given path, and again then bytes per pixel and the width and height and stuff like that. So again, some basic. This is pretty basic Java code. There's some extra magic here if needed, so you can rotate an image. I think
this probably just makes sense if you have a square.
Yeah.
Well, the rectangle you can turn by 180 degrees and put it on its head.
Yeah, indeed. And then the color value of each pixel in the image is read as an RGB value, like this, and it's put in the byte array. So that's just loading an existing image into a byte array. And then there's another method, image to matrix, and this does the conversion from just X and Y values like they are read from the image into this twisted columns up and down and columns up and down. And to be honest, this really gave me a headache. The code, if you now look at it, is pretty simple because so for every even column, you have to start counting down and up, something like that. So I've spent several hours to end up with these 4 lines of 4 lines of code. But it works now. That's the main.
I think what you did here is probably actually something that if we would have had a graphics card and tell him to do a matrix rotation or something like that, it would have done it in 1 line of code. I think this is something that graphic cards love to do because they have to do it a lot.
But here, it's just some trial and error until it worked. I'm very good in trial and error. Okay, back to 8. Oops. So in this example that I created with the 8 by 32, so I have all these images here. And then again, it's playing with byte arrays. First, check the position of the LEDs just to know how they are wired. So that's how you get this up and down effect. So 1 pixel at a time being red and all the other ones being off. I also did all white because I didn't have the 40 amp power supply yet. I had another, how you call it, a Labo power supply where you really see the ampere usage by the device that's connected. So I turned on all the LEDs to full white to just see how much amps this matrix is using. And then it's running through the test images and putting every test image on the matrix. And then at the end, again, some random colors. Okay, I had it running a few moments ago, so let's do it again and then not stop it somewhere in between.
It's a really nice solution that you came up with there to use the color.
So this is first to identify how they are wired. So it's really LED by LED. Now it's full RGB, full white. And these are the images where 1 line is drawn, images in each color. These are the Raspberry Pi logos and tests somewhere in between. Yes, this is Raspberry Pi logo. And then some random colors. My camera is not that good for this use case. Because, you see that it has some troubles to film this correctly. By the way, I'm using Raspberry Pi cameras. Of course.
Oh, nice.
Good.
What I wanted to say is that it's really nice that you use the...
Robert, are you still here?
Yes, actually I am.
I'm not sure. I think your camera is frozen, Robert. He'll come back.
I hope. You hear me?
Ah, the joy of life.
Do you hear me?
Can always go wrong, as I said before. I also have an 8x8 example, which was created by Robert. And I will just execute it.
You don't hear me,
It's using
Frank?
the same code.
This is annoying.
And you see, even on my 8x32,
now?
it's executing correctly. No, Robert, we lost you. We had a little problem before we started with the live feed, and it seems now we have the same issue again.
So yes, I am actually here.
There's another one I want to show you, and that is with JavaFX. People who know me know that I really love JavaFX for creating user interfaces. And the fun thing is that that also works on the Raspberry Pi, of course, because Java is write once, run everywhere. And that's also what we can do with JavaFX on the Raspberry Pi. And again, this is everything inside one JBang file. Let's see if we have Robert back. So we have dependencies which are linked to JavaFX. We have the same serial dependency for the communication with the Pixelblaze. We need some more imports, everything related to the layout that we're going to use in this example. And in this case, you need to install another Java because we need a Java SDK with JavaFX, and we can use the Liberica one in this case. So I'm using here Java 20 to run this example. And then you can execute it with, again, just simple JBang command. So what this will do, it will create a screen with a color picker. And it will create a color picker for each LED. So we defined here that we have 11 LEDs. And then want to put them all on the same color and a clear button. And each of these color pickers and also the button have a set on action. So if you click on the color picker or you click on the button, it will call the helper to do something, like, for instance, here, turn everything off, or here, send the colors, or send all. So these are methods that we find here. Send the colors, send the selected colors to the LED strip, or here, send one color to all the LEDs. Okay, so let's execute this. Pixelblaze output expander JavaFX.
So yeah, you do hear me now, right, Frank?
Okay, so we have the screen. Let me first show you the screen. So this is what the screen looks like. So we have a color picker for each of the LEDs. We have a color picker to put them all on the same color, and we have a clear button. So let's see how this behaves. So if I select red, for instance, for the first LED, then you see that it turns everything white, as that's the default color being selected in the color picker. And the first one is now red. We can put another one on green. And the last one on blue. Voila, you see. We have also a clear all button. And we have all red or all yellow, or any of the other colors that are available here. The color doesn't always look exactly the same as in JavaFX interface, or as you would expect from a web color, and that's just because these LEDs are very bright, and maybe you just need a darker color to have a green effect like you see now. Okay, clear, good. That was the JavaFX example. And I see that Robert is trying to connect again, but without luck. But I think we're nearly at the end of what we wanted to show. This is just a demo again. Okay. I want to invite you to experiment with the Raspberry Pi with Pi4j. The most important website or web link to remember from this presentation is pi4j.com. You can find all the information there to get started with Java on Raspberry Pi, JavaFX on Raspberry Pi, electronics, or if you're really new to electronics and have never done something like this before, there are getting started tutorials here with the minimal example being just blinking a LED, a single LED, and a button, reading a button and having these interaction between them. There's also JavaFX here. There's information about game development here with FXGL, which is also really great if you combine it with a joystick, so you can create some arcade game-like thing with the Raspberry Pi. All that kind of information is available on the Pi4j website. Okay, and one more thing to show you. So Pi4j, the code, the project lives on GitHub. We are on the second version of the Pi4j library, so Pi4j v2. And if you have questions about something, you can join the discussions here. We also have issues, of course, but that's really if you find a bug or have a problem or something is missing in the software. We also had our first Hacktoberfest contribution this month, so thanks for that. And in the discussion, you can find more information. We also have a Slack. Ping me if you want to join the Slack, where we can also have some discussion about this library. Okay, it's a pity that Robert cannot connect anymore, but I really want to thank him for his time to also join this live feed, and for the examples that he also created with JBang within this project. I hope that we can do this again, hopefully without any technical issues at the time, and that we can learn you more about the fun of playing, experimenting with electronics and Java and the combination of both of them. Have a nice evening from my side, and see you later. Thank you.